సో బ్యాకప్ ఇన్ ద డేటా. సో మనకు ఏంటంటే డిఫరెంట్ ఎన్విరాన్మెంట్స్ ఉంటాయి కదా. ఈ డిఫరెంట్ ఎన్విరాన్మెంట్స్ అంటే డెవ్ ఎన్విరాన్మెంట్ ఉంటుంది, క్యూఏ ఉంటుంది, ప్రోడ్ ఉంటుంది. ఓకే, సో మల్టిపుల్ యూజర్స్ ఉంటారు. ఇన్ దట్ సినారియో సో నీకు ఒక వర్క్ చెప్తా. సో నువ్వు ఫస్ట్ ఆఫ్ ఆల్ మనం రా డేటా రిసీవ్ చేసుకుంటావు కదా. సో మన డేటా కన్సిస్టెన్సీ అని ఒకటి ఉంటుంది. మనం ఏదైనా డేటా మెయింటైన్ చేస్తాం. సో కన్సిస్టెన్సీ అనేది మెయింటైన్ చేయాలంటే మనకు సోర్స్ నుండి డేటా ఎలా వచ్చింది, కాలమ్స్ ఎన్ని ఉన్నాయి. సో మనం ఫైనల్ గా అవుట్పుట్ ఇస్తాం కదా. సో మనకు ఆ డేటాలో కూడా కాలమ్స్ అన్ని ఉండాలి, ఆ డేటా ఉండాలి. సో మిస్ అవ్వకూడదు డేటా కన్సిస్టెన్సీ అది మెయింటైన్ చేయడానికి. సో మనకు డేటా తర్వాత మనం ట్రాన్స్ఫర్మేషన్స్ కానీ డూప్లికేట్స్ వాల్యూస్ కానీ చేసి డిలీట్ చేస్తాం కదా. సో ఏది మిస్ అవ్వకుండా మనం ఒక బ్యాకప్ గా చేసుకుంటాం వచ్చిన డేటాని యాజ్ ఇట్ ఈస్ గా. సో అదొక పాయింట్. సపోజ్ దేర్ ఆర్ మల్టిపుల్ యూజర్స్ దే ఆర్ వర్కింగ్. సో యూ హ్యావ్ there is one EMP table. You're going to work on some transformations. So some other person, other user is going to work on some another transformation, other implementation. The same table. On the same table. So in that scenario, they will clone that table and they're going to use on that transformation on that clone on the clone table. Okay. Then they will use same table, but they have different names. So like that, they will clone and they will use base table. Base table. One is for backup, and if one more is for the there are multiple users. At the same table, if they want to work, they're going to use. Base table ni change చేయకుండా clone చేసుకుని transformations like that transformation they use to clone the table. Yeah, like that they're going to use. Okay. So నేను సబ్జెక్ట్ మొత్తం చెప్పిన తర్వాత డౌట్స్ అడుగు. ఓకేనా, కంప్లీట్ చెప్తా కదా. సో పాయింట్ అవుట్ పెట్టుకో, రాసుకో, అప్పుడు అడుగు, వాళ్ళు వింటున్నారు కదా. ఓకే, సో నెక్స్ట్ so we have micro partitions, right? So one type of micro partitions. Okay, so these are micro partitions. They will ask about, so that is normal thing, cloning independent table, both the tables are independent. When you do DML operation, it's going to have the storage and storage cost, normal things. But so nowadays they will ask me about partitions of the about base table and clone table. Okay, here. So what I mean, there is base table I created. So now it's going to have like this some partitions. Okay, so after I'm cloning this clone table, it's going to fetch data from the these partitions. Okay, metadata. Okay, suppose I'm inserting new data in the base table. So remember, let's see. So in base table, I'm going to insert after cloning. After cloning, I'm going to after cloning, I'm going to insert data in base table. Then what will happen? So it's going to rearrange the partitions and it's going to create the new partitions. Okay, it's going to rearrange the partition and it's going to create the new partitions. This one. Okay, so now in clone table, so after cloning, so I'm inserting the data. What happened to the partition? I'm inserting data. I'm inserting new data. So then what will happen? So the clone table is not going to disturb this base table original partitions. Okay, remember. So the clone table is not going to disturb original base table partitions. Separately, it's going to create the new partitions. Clear? Remember this part. Okay? So it's a new data. Then it won't disturb. It won't disturb like original partitions. It won't disturb. Okay. It will create new partition. New partitions. So new partitions, remember this point. Okay, this one. They will ask, okay. So base table having the micro partition. If we insert new data in the base table, it's going to rearrange the partitions and it's going to create some new partition. But when we insert in the data in clone table, so it's not going to disturb this original base table partitions. So it's going to create new partitions. Okay. So even if you drop the base table, okay, as per the time travel, so these micro partitions also going to delete from the entire database, but still we have metadata in the cloud services layer. From that, the clone table going to fetch that data. Okay, remember this point. Okay, so now see a clone table don't have the storage and storage cost. Okay, it will have the only compute cost. Okay, so after cloning, both are independent. So clone table have only the compute cost. Okay. If you do any DML operations like insert, delete, update, then clone table have the storage and storage cost for that data only. Okay. Okay. Next, if you drop the table, still going to fetch from the if the partitions are available, then it will go with the partition as per the time travel. If there is no partition, it is going to fetch from the cloud service layer metadata. Okay. So this So after cloning, if you insert data in the base table, so we're going to rearrange the partition, we're going to create a new partitions. But if you insert data in the clone table, it's not going to disturb the original partitions. It's going to create new partition. So remember these points. So they're going to ask only these questions from the in the interview. Okay, these are only they will ask to this point. Okay, so check and doubts. Clear? Nick, Rajesh, Avinash, Praveen. Avinash, Praveen. Doubts ఏమైనా ఉన్నాయా?
No, I don't have.
క్లియర్ కదా?
Clear.
Okay. Next. So constraints చెప్తాము. ఓకే. సో మనకు స్నోఫ్లేక్ లో సెలెస్టర్ ఫ్రమ్ ఈఎంపి. ఓకే, బేస్ ఈఎంపి టేబుల్. ఓకే, సో I'm inserting data. Okay. This is the EMP table, right? Okay. So now we have the duplicate data. 3 CC and salary. Okay, so we have duplicate data. So but when we are selecting DDL, get DDL of input table, so it's going to have this one. Okay, so now we have the not null and primary keys. So primary key is ID, right? Okay, we given for the ID, but still the data when we loading into the input table, so it is still it's accepting the data, duplicate data, 3C. But suppose take like Oracle SQL Server, try to give primary key constraint, try to load duplicate data, it won't accept. It will throw the error. It will throw the error. But Snowflake will accept the duplicate data also. Why? Because of it is a so where from the multiple sources we going to receive the data on ESC file, JSON files. So it should accept the duplicate values also. Okay. In Snowflake, it won't support for the constraints. Sorry, not enforce for the constraints. Force. Not enforce for the constraints. Okay? It means not enforce constraints like unique key, primary key, check, deep, like date, some other constraints we have. Okay, so Snowflake are not enforce the constraints. They will ask interview. So what are the Snowflake enforces the constraints? So we need to not null. So not null only it going to enforce. It's going to enforce only not null. From the Snowflake construct, we have different constructs like unique key, primary key, foreign key, not null, check. So Snowflake only enforce, okay, only not null. It not going to enforce the primary key, unique keys. Okay. So remember this point. Into they will ask. So what are these Snowflake? What are the constructs going to support Snowflake? Only the not null. So usually they don't use the word support. So instead of support, they will ask, they will use like enforce. So Snowflake only enforce the not null, not going to enforce other constraints. But I'm telling, but Snowflake enforce, but only one default key. So with not null, but default key. It will also enforce the default key, but always go with not null because of so usually they only it only going to enforce only not null, but with my experience I'm telling, so it will also enforce the so default key. Okay, so go with only not null. Okay, but it will also enforce the default key. Okay, go with always not null. It not going to enforce the other keys like primary key, unique key. So remember this point. Okay, then so this is remember constraints like SQL concept, right? Remember constraints. Okay, so one SQL concept. So I'm going to tell you now. Okay, one chaining, right? We have left join and right join, okay? And inner join and full join or outer join, okay? And task join. So you have that like a self join that you have. So these are main joins in the Snowflake. Okay. So now I have table A. So values like 1, 1 and 2, and I have 2, then I have 4, then I have null, and I have null. So these values are having in the so one table A. So table B like having like 1, 1, okay, and again 1.5, and I have 2, then I have 3, then I have so null. So these are table B values. Suppose if we do left gen, so what is going to give? What is the count of left? They will ask. So this is sure question in interview. They will ask surely. They will give table A values and table B values. Some values from this one. They will ask what is the count of left gen and what is the right gen count like that. Inner gen, full gen, and cross gen. They will ask. So, so anybody guess what is the left gen? Have any idea about? Renu, Rajesh, Baker, Ravi, Nagesh.
Match records from the both
So what are the values for the left gen? Tell me. Output. Tell me the output. Hello. Tell me.
all the records from the left table, common records from the both the table. These two.
Okay. So for tell me what are the values? Tell me the I will type for left gen.
Okay.
Tell me I will type. Okay, you are right. You are right. Someone tell right. You are right. So what is it going to give the output for left gen?
1, 1, 1.
Okay, 1 1. Then
Okay. Again 1, 1. Again 1, 1.
okay, again 1 1. Okay.
Again 1, 1.
Again 1 1.
After that 2, 2. Again 1, 1.
This one.
2, 2, 2, 2 null. 4 null.
Okay. 2 to 2 null.
4 null.
Okay. 4 null. Okay. Okay. Properly you're right. Okay. See, first we have 3 ones right here, and here table B we have 3 ones. Okay, so how it going to match? Okay, so this one going to match 1 comma 1 and 1 comma 1. So 1 comma 1. Again this 1 comma 1, 1 comma 1 and 1 comma 1. So like that we have 3 into 3 9. Okay. So 3 into 3 9. This one 3 into 3 9. Like that we'll get 1 comma 1, 1 comma 1, 1 comma 1. This first one. Again, some more values like get. This is for 1. And again we have 2, 2, right? Here we have 1, 2. So it will match with 2 comma 2 and 2 comma 2. 2 comma 2. So 2 comma 2 and 2 comma 2. There is 4. There is no match for 4. It will give the 4 comma. And we have null comma null. So null comma null means not this null. So there is no value because of null is not equal to another null. So one null is not equal to another null. So null comma null, it won't take this null. Okay, null comma is null comma null only. So not this null. So again we have one more null comma null. So this is usually for inner giant. So total how many values? 1, 2. These are 9. Okay. So 11, 12, 13, 14. So left giant count is 14. So again, right giant you can see. Clear? So again, take this we will get this one. Okay, matching and 2 again we will get 2 comma 2, 2 comma 2. This one again, this one. Okay, these are matched. So there is no match for 3. We get 3 comma null, and there is only null. So it will give null comma null. So not this null. So null is not equal to null. Okay, this one. And again for inner giant, so you only match records. Okay. So there is one match, 2 matched only. 4 and null, there are no matches. And 3 null not match. Only match records means so up to this one. Okay, this one. This one. So now fuller giant. Full giant or outer giant you can like left giant plus right giant. So it means you're not going to give directly left giant plus right giant. So first take these are common, right, in the both tables. This one common. Okay, these are common in the so both tables 1 1 2 2. Okay, then from the left giant we are getting these values, and from the right giant we are getting these are values. It won't repeat the common values again. Okay, this is the full giant. So cross giant, how it going to be? See, suppose taking the sketch. Cross giant means okay. So this one we have 1 comma 1, 1 comma 1, 1 comma 1. Start. So 1 comma 1 and again 1 comma 1, 1 comma 1. So 1 comma 2 and 1 comma 3 and 1 comma null. Like that this one. Like that this one. For everything. Again it will go everything. So each value. Suppose how to tell Rajan means. So take how many that in table we have 1, 2, 3, 4, 5, 6, 7, 8. 8 into here in table we have 1, 2, 3, 4, 5, 6. So 8 into 6. Like we have 48. So 48 we have from this one. Okay, remember this point. 48. This is like cross join. So remember first take inner join. See 3 comma 3 we have 3 here and we have 3 ones here. Just multiply. So right multiply. So total 9 values. Total 9 values. 3 into 3, right? 1 1 1 1 1 1. Okay. 3 into 3 9 values. Then check another value. Okay. 2 2 2 2 common values. Okay. So 1 1. Okay. 2 here 1. So 2 into 1 2. So 2 values. Okay. So after that this is like inner join. Okay, it want there are 4 null null 3 null not match. So this is inner join. For left join after matched values then so there are no matches, right? There is no matching for 4 and null null. So we need to give in the left join. For right join after matched values, okay, after matched values, so we need to check what are the not matched values, unmatched values. So 3 and null is not matching, we need to give like that. So for full join outer join, it is left join plus right join, so we need to take the common values. Okay, common values, then after we need to take the values from not unmatched values from the left side. Okay, and unmatched values from the right side. Right side. So this one. So simple cross join, like what are the values, just count, and what are the values in table count, just do the multiply. Okay. So they will ask for the count. Okay, we need to count this one. For this week given 14. Again we need to count this one 9, 8, 10, 11, 12, 13. Okay, count is 13. Here the count is okay 14. Again inner join we need to go on to 9, 10, 11. The last level. So outer joins again, okay, same 14 and this one 15, 16. Like this. Okay. So this one directly you can say multiply 40. Okay. They won't ask type what is the output. Okay. They will ask count 14, 13, 11, 16, 48. 48. Suppose if they ask, you need to go with, you need to tell this output. Okay. So tell me, they will ask count. If you tell 14, so what are the values? Just tell me. So you need to go with tell 1, 1, 1, 1. Okay. This type you need to tell. So count of left join, right join, inner join, full join. Right. Suppose if you do same thing in the chart GPT. So like so chart GPT, it won't give the properly. It give not properly join. Okay, it giving only 11, but actually in real time we will get 14. Okay, so when we working with giants, don't take from this one, it will give only 11, and for left giant it's giving 14. It's properly fine. 14 is fine for left giant, fine, but for here inner giant giving 11. So or 11 it's giving fine sometimes. Okay, and 11 given left giant, right giant giving 13. Okay, 16. Okay, so previously it's not giving properly 11, 14, 13, 16, 48. So but it's okay. Now it's giving 5. We have everything right here. But this is premium, right? The premium one giving properly, but if you without premium, it won't give the properly output. Okay, so when we working with the chains, you can check like this data, then you can try. So even it is fine for the 14, 13, 11, 16. So 48. So it's given properly only. So what? Always go with only this method only. Sometimes it won't give the properly. And only change. Okay. So always go with this method. Then you will get an easy idea on these joins. Okay. So if there is any time, okay, after teaching the concept of that day, so I will go with some SQL concept also. So we're going to discuss those concepts like we have pivot and pivot, okay, deleting duplicate values, okay, rank, dense rank, row number, uh, and in Snowflake indexes won't support. Instead of indexes, we have partitions and cluster keys. Okay, so those they will ask about what is the difference between rank, dense rank, row number. Okay, what is the difference between rank and dense rank? What pivot to, unpivot to? What is list tag? Okay, pivot list tag, list tag, LASTAGG. Okay, and what is cumulative sum? They will give some values. They will ask cumulative sum and find highest salary, second highest salary. Okay, find average salary department wise. Okay, what are these sub queries we have? Okay, sub queries. Okay, those are okay, like that. They will ask on the SQL. So first they will check with on Snowflake. Then after they will ask how much you can rate yourself on SQL. Then go with these tasks. Only repeated only. Everything repeated. Some scenarios they give 10 tables. They ask you, they will give an output or they will tell to write a query for that output. Like that they will ask. Okay. So in our time we're going to discuss about these features. So today concept is like our zero copy cloning is go with those. So remember this thing, okay? Cloning, independent, partitions, okay? Storage cost. So these only they going to ask. So in real time for backup, we're going to use for the data, maintaining the original data, okay? And in future if you need for data consistency. And also there are multiple users are working on the same table. In that scenario, we're going to create these going to clone the data, so without duplicating data, storage cost. Okay, so we can clone even database also. Okay, they clone the database also. Okay, so create database. Okay, uh, the clone, so clone of this one I need to tell, right? Okay, suppose one thing. Suppose when you run in the query, uh, when you running the query for that previous what you have run, you need to close with this semicolon. We don't close, you will get the error. Okay, you can close or you can use the comments like you can use hyphen. Then try to run. Now it's going to read about this one. So comment here. Okay, then comment here. And then go to comment here. Do this comments in the Snowflake. Okay, already exists. We created. So already we created the object dropdown already exists associated. So now go to new worksheet. Go select raw clone. So inside we have clone schema, public, shop schema, everything. What are we having in the raw database? Clone schema, public shop. Even we have the clone table also. Clone schema, public schema, shop. Okay. Now I'm selecting a clone schema. Okay. Now raw clone. So four tables. Going to show all data in the raw clone database. Okay, even if you check, so same tables we have in the this one database. Raw database. Clones. So even we have every data in the table. base database also. With this, okay? This one. In GMP clone CTS, right? This. Okay. So this one. You can clone database schemas or anything as per the requirement. Okay. So we will. So this is about the zero copy cloning. Okay. So tomorrow we will go with the time travel. So how to access the historical data, and also we go with the table types also. Okay. So as of now, clear, right? Any doubt in the session? Avinash, Praveen, Rajesh, Shekhar, no, right? Okay. Okay, we will connect tomorrow. Huh? Same 10 a.m. So if I don't share link, no worries. I will share the link 10 a.m. If there is no class, I will inform you before only. Before only. I will share sure 10 o'clock link. Okay, be on. Tell me, Praveen. Clear it?
Clear.
Okay, Avinash. Okay, Avinash. Bye.